Hi everyone, today we're going to talk about continuity and limits. We're also going to identify different types of discontinuities. Get ready to unlock the power of math together. Let's dive right in. Okay, so the graph of a continuous function has no holes or breaks or graphs. So you can trace your function without ever lifting up your pencil. So something like that. Okay. Now, for a function to be continuous at a particular x value, your graph has to approach the same y value from the left and of the right. That's why limits are necessary to determine whether a function is continuous or not. So to better understand continuity of functions, we're going to look over different types of discontinuities that can occur. So a function can have an infinite discontinuity. So that would be typically where you would see the asymptotes, right? So your value, let's say, would increase or decrease indefinitely as x approaches that c value from the left and from the right. Your function can also have what's called a jump discontinuity. So you literally will see going from one value jumping to another. So you have two sort of distinct values. Now these two are called non-removable discontinuities. Okay. And then your function can also have a removable discontinuity if the function is continuous everywhere except at a hole, right? So you're going to have a hole here, right? This is your removable discontinuity. So in order to test for continuity at a particular point is a three-step process. So your function is continuous if you have the following conditions met. Now your function is defined, right? So if I take a value at c or at 5 or at 8, right, there is a value there. Now the function also approaches the same value from either side, which means your limit exists. And the value that your function approaches is also when you evaluate that same number. So your limit value equals the value that your function is defined at. All right, so now we're going to see, is g of -1 defined? Here's -1. Is it defined? Yes. Yes, it is. Why? Because you have a value at 2. Now we're going to evaluate the limit. X approaches -1 from the left. That's at 2. Okay. The limit as x approaches -1 from the right. That is at 1. The limit as x approaches -1 does not exist. Okay. The limits are too different from the left and from the right. So is your function continuous? No. And the reason being is you have a jump discontinuity. Jumps from one value to the next. Okay, so is f of -4 defined? Here's -4. Is it defined? No. You have a hole there. So let's figure out what's the limit. From the left, you're approaching 5. From the right, you are also approaching 5. So your limit from the left and the right are 5. Now, is it continuous? Okay, is your function continuous at -4? No, it's not. Why? Because you have a removable discontinuity, right? You have a hole. Is f of -1 defined? Yes. You have a value, and that's at 2. So the limit from the left is at 2. The limit from the right, also 2. So the limit is 2. Is this continuous? Yes. Okay. Your limit is equal to the value that your function is defined at -1. Okay. Is f of 2 defined? No. You have an asymptote there. So let's see. Approaches from the left, goes down to -infinity. approaches from the right, positive infinity, limit does not exist, two different values. Is your function continuous? No. And why not? You have an infinite discontinuity. You have an asymptote there. Okay, so we're going to evaluate all the discontinuities here and the x value that they occur at. So let's start from the left-hand side. Here at -6, you have a jump discontinuity. You're going from -1, going all the way jump into 4. Okay, here at -3, you have a discontinuity. You have a hole, so you have a removable discontinuity. Let's see, -1, you also have a removable discontinuity. You have a hole. At 3, right here, okay, you have an infinite discontinuity. You have an asymptote. And at 8, again, asymptote, infinite discontinuity. Thanks for learning with me today, unlocking the power of math one problem at a time. Don't forget to like and subscribe for notifications on pre-calc videos.